Good evening, everyone. May I start the session?
Yes, ma'am. Yes.
Okay, sir. Thank you.
Yes, ma'am. Please wait for a few minutes, ma'am. So I will check it our HOD is there or not. Okay.
Okay, ma'am. No issues.
Vignesh sir, can you share your PPT, sir? Can we check it?
Yeah, ma'am. I'll share now.
Yes.
Is it visible, ma'am?
Yes, sir. It's visible.
Okay.
So welcome one and all present here. Soumya ma'am, please.
Yes, ma'am. Good evening to one and all. We are delighted to welcome our esteemed dignitaries, eminent resource people, academics, researchers, and all energetic participants. On behalf of VISTAS, it gives me great pleasure to welcome you all to the faculty development program on cloud-based data science, architectures, tools and best practices, organized by the Department of Applied Computing and Emerging Technologies. To formally commence the program, I now invite Dr. Devi, Professor and Head of the Department of Applied Computing and Emerging Technologies, VISTAS, to deliver the welcome address. Over to you, ma'am.
மியூட்ல இருக்கு மேம், மியூட்ல இருக்கு.
Good evening, one and all. It gives me immense pleasure to warmly welcome all the distinguished resource persons, faculty members and participants to the 5-day faculty development program on cloud-based data science, architectures, tools and best practices for scalable analytics. At the outset, I would like to express our sincere gratitude to the management of VISTAS for their visionary leadership, continuous encouragement and strong support in fostering academic excellence, faculty empowerment and technology-enabled learning. Their commitment has been instrumental in organizing meaningful academic initiatives such as this FDP. In the present data-driven era, cloud-based data science has become a vital enabler for scalable and efficient analytics. This FDP is designed to provide valuable insights into the modern architectures, tools and best practices with a balanced focus on theory and practical applications over the next 5 days. We are thankful to our esteemed resource person, Dr. Vignesh Ramamurthy, Associate Professor, Department of Computer Applications, Amity Institute of Information Technology, for sharing his expertise, and we appreciate all the participants for their enthusiastic involvement and commitment to the professional development. Confident that this program will be highly enriching and rewarding for everyone involved. Once again, I warmly welcome you all and wish you a successful and engaging FDP. Thank you.
Thank you, ma'am, for such a warm and inspiring welcome. I now would like to invite Dr. T. Kamalakannan, sir, to introduce our chief guest to the audience.
Good evening, one and all here. Okay, I welcome you, sir. Dr. Vignesh Ramamurthy, sir. He is a MSc Software Engineer, MCA, PGDMC, PGDLT, MPhil and PhD. Now he is working in a program lead and associate professor in Amity Institute of Information Technology, Amity University, Bangalore. He has had more than 15 years teaching experience. Also finished PhD education of PG diploma in English language teaching, Annamala University, and a PG diploma in mobile computing, Annamala University. So also it participated in the technical advisor for RK Creative Solution and also creative head for iGuilders Technologies. She is also published more number of papers and also finished short-term courses for career building and mastering the interview, CS University, Australia, Computer Network Fundamentals, CS University, Australia, Cyber Security Practice for Industrial Control System, US Dependent Homeland Security. So also for this area of interest is mobile computing and advanced networking, artificial intelligence and machine learning, teaching and learning pedagogy, and design thinking. So also he has also international exposure. He trained 50 students of Jamaica, North America on web development from 9th to 13 August 2001 through online mode. Education visit to Linton University College, Malaysia. Factory visit to Yogurt Factory, Malaysia. So he also guide the research students. For one, we finished one MPhil student and one PhD students. Also participated in the media. The participated in show called Nambal Mudiyum, organized by Target Zero on Environment and World Convention Trust, telecast by Pudhiya Thalamai Televisions. So also you get more than 50 awards I got. The best, one of the few of these 7 best papers award for conference papers. Research grant DRDO 3 lakhs rupees, CSRO, ICSSR, RBI and TLCT got grants from the particular agencies. Emerging Academician of the Year 2010 was the International Journal of Innovative Research and Growth Energy. Guru Dono Award by Master Academic of Commandant and Research Private Limited, September. Young Educator and Scholar Award by National Foundation for Entrepreneurship Development in Coimbatore, Chennai. Coimbatore, September 2021. Best Faculty Award by Chennai Teachers Club, Chennai, April 2021. Dr. APJ Abdul Kalam Young Teacher Award presented by International Organization of Innovative Research Publishers in IRP. So there he got more than 10 awards for the experience teaching awards. And also accreditation for he has published more than 15 books and honor certificate finished 4 than 45 and a patents he filled for 5 and book chapters for 14 and editors in 7 books and journals. Editorial board member for more than 25 journals. Paper publication in international journals more than 51. Conference section chair and invite talks and mentor for more than 110. Paper presentation international conference 71. Paper presentation national conference 58. Participate in workshop seminar FTP 31. Participate webinar and FTP 72. She has actively participated in many innovative projects and professional bodies and seminars. So I welcome you, Sonia, sir. Thank you, sir.
Thank you, sir. Sir, ma'am, shall I start?
Thank you, sir, for your wonderful introduction. I now invite Dr. Vignesh Ramamurthy to kindly take over the session.
Yeah, thank you, ma'am. So before starting, I would like to thank Dr. Booba, ma'am, for inviting me as a resource person. Thank you, Booba, ma'am, for your continuous support and the opportunities. Thank you. And thanks to Gayatri, ma'am, Soumya, ma'am, Dr. Devi, ma'am, and Dr. Kamalakannan, sir, for your welcome address and introduction, respectively. And thank you, everyone, for joining us today for knowledge sharing. So without further ado, let me start the presentation. Today, day one of FTP, we are going to start with the foundations of cloud-based data science. So the FTP on cloud platform for data science, where the 5 days you will be involving in learning about different tools, technologies, practices, architectures, all about the cloud and data science together. So let's get into the presentation. These are the contents we are going to discuss today. We'll start with the introduction and we'll see how evolution of data science is done with the cloud and what are the core cloud computing fundamentals. So we will have a quick recap or understanding about cloud. So some of the faculty members or participants here would have came across cloud computing. So we will just cover a few fundas and we will try to understand what are the different architectures on based on cloud and data science together and how the data science life cycle in the cloud works. We will come across some of the tools and technology stacks that is meant for data science and cloud. And at the end, we'll have a quick discussion on challenges and best practices and how the future technologies of cloud and data science will be. So this is what the agenda of today. So what is data science? We know data science is having 3 different technologies. It has maths and statistics. It has computer science. So it has business knowledge. So combination of all these 3 things are called as data science. So it's an interdisciplinary field where it can extract insights, predictions, and knowledge from both structured and unstructured data. Of course, without statistics, data science cannot run. So machine learning and data science with the domain or business knowledge work together to formulate the data science. So this is what the basic understanding of data science that we have. So now why cloud has to be taken for data science? Why we have to combine or integrate data science with cloud? What is the need? Okay, so we know traditionally all the systems are on premises. So all the companies' infrastructure are physically created. That could be server, that could be any technology-based architecture. So everything is on-premise system. Okay, so what is the problem with the on-premise system? That is called as traditional system. The first thing is the scalability is less. That is limited scalability. We cannot extend it further. If you wanted to do any improvisation, it incurs a lot of cost. It takes a lot of time to implement. Okay, so there are a lot of resources requirement is there, which will end up in a massive expenses. So to avoid that or to make your system updated with low cost, we have to go for cloud environment. Okay, so as we discussed, the cost of infrastructure is high, and the setup time or duration time is long, and we have the maintenance overload also. So toward all these things, we have to think about, we in the sense the industries and also the educational institutions, because educational institutions are also maintaining a lot of data. We have student data, which includes marks, uh, their complete details, which include, it starts from their roll number to their phone number. So we have a lot of data about student. So when you wanted to refer the student data, where we have a requirement to store a voluminous of data. Okay, and the maintenance of data is also very difficult. If we switch over to cloud, so that efficiency will be there, and there will be a positive progress. Okay, so cloud will solve this existing problems, whatever it is done in the traditional method. So it can give you the on-demand resources. So to construct any, let it be an industry or an educational institution, there are a lot of resources required, and certain resources are not vital, but still the companies, the industries, or the institutions buy it as a mandate. Okay, so we can go for a choice that is on-demand resources. We need not get all the resources, the vital resources. We should create the list of vital resources. Those are called as on-demand resources. Only those resources we are going to buy it. Okay, and this can give you the elasticity in the scalability. So previously, when we are talking, we understood that the scalability is limited, but here it is flexible. You have a possibility to extend the scalability. Okay, and this is called, as we know about cloud is like pay and use it. So it's like rental. You can pay for what you use. You need not pay for everything. You pay for only the resources which are required, which are vital. Since it is connected remotely, you have a lot of options to connect from a different place. Okay, so thereby we end up in having the global accessibility. So once we have global accessibility, the ease of use is there. There's a lot of convenience to use it. So the resources are readily available, and it can be very useful. Okay, so the final message here is modern data science is no longer laptop centric, it is a cloud native. So whatever the data that we are maintaining in the local database or any a simple server to a complex server, when we switch over all these things to a cloud-based environment, there will be more advantages than the traditional system. And now we'll look into the evolution part. So how evolution has taken place for the cloud-based data science. So it started with traditional system, and it is moving towards the cloud-based science. Okay, so here the traditional data science setup is these are the things that is happening in the traditional setup. So it requires upfront hardware and infrastructure investment. You have to invest a lot of money for it, and there needs maintenance. You need people to take care of it, because it's all physically available on the premises. And when you wanted to update an infrastructure, a machine, that costs a lot. Okay, and we know every day there are new technologies are coming. Okay, every day there are new techniques coming. If you wanted to go for a new hardware, updated software, that will be very expensive. So as we discussed, the accessibility is also less, the duration for working is also more. And when we are talking about the real-time analysis and handling the big data, the support is very less. Okay, and what if there is a disaster, maybe a earthquake or a flood or a hurricane is happening? So your data center, which is stored in a on-premise physically, that there are chances to the data, either the data will be lost or destroyed. So you have to manually create a backup and disaster recovery. That again costs more. Okay, So these are the drawbacks in the traditional system. So when you go for cloud-based data science, you can pay what you take it. So no upfront hardware cost. Okay, and it automatically updates everything. So whatever the recent software that is available in the market, you can go for it. You need not go for the obsolete systems or the traditional systems or the old systems which cannot support your working environment. And since we have the global accessibility, you can use the internet and connect from anywhere. So you have chances of storing all the data. So backup and recovery is also good. Okay, so these are the advantages with the cloud-based data science. And we know AI is evolving. Artificial intelligence enables to have automated backup and helps you in security and disaster recovery. So all these AML technologies can be combined um, uh, from data science can be combined with cloud. So the advantages and features of AML can be taken and help you. This will help you to improvise the cloud performance. So simple and quick comparison. So traditionally we were storing in the local disks, and now we have the object storage, and computation were very fixed in the traditional, and now we have elastic, that is flexibility is there. And cost wise, the expenses are more in traditional, and cloud based, it is only operational expense. You're not going to spend money for the infrastructure. Instead, you're going to spend only for the operations, okay, in the process. And collaboration is very limited in traditional, and cloud-based this is seamless. So when the understanding of the comparison is cloud-based is good. This has a lot of advantages. Now let's get into the core cloud computing fundamentals. So these are fundamentals. We know that cloud has three different platforms: software as a service, platform as a service, and infrastructure as a service. Let's understand it one by one. So let's start with the infrastructure as a service, IaaS, which is shortly known as IaaS. So this is like renting a computer, empty computer lab. So in our university, in our college, in every institution, there are labs, right? So imagine you have an empty computer lab. So that is infrastructure as a service. So the university or the college will give you a room, they'll give you the power, they'll give you the machines, computers, right? But you have to install everything. This is infrastructure as a service. So cloud environment will give the basic hardware configuration system. We have to do the installation. We can use this tools whichever we require, like virtual machines for storage, because when you're depending on cloud environment, we need place to storage, and also networking resources, because you're connecting in internet and sharing of data, and you can work globally. Remote access is there. So three important things under infrastructure as a service is like getting virtual machines and storage and networking resources, and what we can manage. Okay, so what we can manage is we can manage with the softwares. That will be a software application or operating system, and whatever the patches. Audience, could you please mute? Yeah, if you have any questions, you can ask.
Kindly mute, ma'am.
Okay, thank you so much. So we have the operating system, the software application, security patches, and runtime. And these things we can manage in the infrastructure as a service. So we all know about AWS, Amazon Web Services, and Azure application, and Google Computing. These are three important cloud platforms which are very popular. Okay, you can manage the OS and software in the infrastructure as a service. Second thing is platform as a service. Here, it's about, see, as we discussed previously, it's an empty lab. Now we will get a fully equipped lab, so which has computers, operating systems, and software. So these will be ready. So in infrastructure, you have an empty lab, but here you have a fully equipped lab, and here you have to just perform the experiment. So what you get here is a pre-configured runtime environment. You have an environment where your databases, you have to, which is developed. Okay, so what you have to do is you have to do the coding and data part. You have to manage the code, and you have to manage the data. Okay, so like you can use Google's App Engine, Azure application services, and AWS Elastic Beanstalk. These are the tools that can be used for platform as a service.
Ma'am, kindly mute, ma'am.
Vilkesh K, sir, please mute your audio.
Participants are requested to mute.
Okay, they are very busy, fine. So next is software as a service. Here we have the university library. It's like university library. Everything is ready. You just use the service. So the cloud platform gives you everything. It has fully managed software. It has automatic updates and all the security backups. Everything is ready. Everything is kept ready. What you have to do is you have to use only the service. I think you would have used these tools. Gmail is very common. Everybody would have used Microsoft Office 365. Also, everybody would have used. Apart from that, I think people who are teaching data science, who are learning data science, they would have already explored Power BI and Google Colab. So even whatever the codes that we do in the university for students, we ask them to work on Google Colab because that is a cloud environment. It can be used anywhere, and you have the global accessibility. So all the codes they will be executing it in Google Colab, and you can later push it in GitHub. So software as a service, you will focus only on the tool. So there is no installation required because all the setup is completely ready. Okay, so you can do a customization and use it based on the requirement of based on your needs. You can do it. So these are the three important core cloud computing foundations, which is infrastructure as a service, platform as a service, and software as a service. Okay, so IaaS, that is infrastructure, will control everything except hardware, and platform will concentrate on the control applications, not the infrastructure, and software as a service will use only the software. Next comes the cloud deployment models. So we have different deployment models. We have public cloud, private cloud, community cloud, multi-cloud, and hybrid cloud. So we'll see one by one. So public cloud. So public cloud has different resources like servers, storage, and applications. So this will be owned and operated by a third-party provider. So whatever internet connection we are having, there is a service provider. We are having Jio, even phone, SIM card, right? We have Airtel, Vodafone, Jio. There are many, service providers like that. Public cloud will be given by a service provider, like Amazon or Google. You can pay and get it. Okay, so they will be delivering everything to the internet. Okay, so this is for general use. That is called as public cloud. So we'll be paying to a third-party provider and using it. That's a common platform. Okay, so here the infrastructure is shared with many users. So you will not be, you will be sharing the platform, okay, with many users, and this is cost effective because since you're having a sharing infrastructure, the cost will be less. So private cloud will be very expensive comparing the public cloud, and this is also scalable. And here all the maintenance and upgrades will be taken care by the third party provider. You cannot customize it, you cannot modify it, or you cannot upgrade. You can ask for an upgrade. Okay, as a client, you can ask for an upgrade, but this upgrading part and maintenance part will be taken care by the service provider. Okay, so this is mainly used to maintain or manage the costs. So like examples like hosting websites, development or testing environments, startups, we can use this public cloud. Okay, next is private cloud. So here this is a dedicated cloud. So this is dedicated to a single organization. Say for example, Amity University wants to use a cloud, they will buy it, and they have a dedicated system. This is meant only for Amity University. Okay, so this is not going to be a shared resource. Okay, when it is given particularly for a particular organization or single organization, the cost will be high. Okay, so this can be on premises or hosted by a provider. Even the provider's place it can be, or if you want, you can put it in the on the premises. Okay, so we have an advantage of making it either available inside the campus or outside the campus. Okay, so the traits here is like the access will be exclusive and better security and compliance because you're not going to have a shared environment. This is a dedicated system, so security will be good comparing the previous one. And there's a full control over resources because it is a dedicated mission. You are the owner. I mean, whoever is purchasing that person is the owner. So they have full, they can customize, they can control the resources, they can change the policies, they can manage the data. So they have the freedom of maintaining everything, handling all those things. So that advantage is there, that flexibility is there. Okay, as I told you earlier, this will be costly than the public cloud because you are going to have a dedicated for a single organization. So cost will be there for the hardware and also for the management. So this will be little expensive than the public cloud. So who can be the users of private cloud? Like banks. Banks cannot use a shared resource because banking needs high security, and government, defense system, for example, healthcare. All these things need security. So they cannot have it in a common shared resource. They wanted to have it in a dedicated system. Third one is hybrid cloud. So talking about hybrid is like mix of private and public. So all the best features of private cloud and best features of public is taken and combined. Okay, so there's a mix of both. That's why it's called as hybrid. Okay, so here the data and applications can move between them. It can be either private or public or vice versa, mix of it. And both the worlds, it has the advantages of both, like security and scalability. It has flexibility, and you can use for, say for example, for very sensitive information where security is required, use private cloud. Where security is not mandate, not important, use public. So you have an advantage of using both. Okay. And the use case, like for the use cases are like compliance sensitive applications running in private. Compliance is like regulations. Okay, so when regulations are very important, policies are very important, very sensitive, you can run it on a private. Or analytics or web applications. When you're talking about analytics, where a lot of people has to use the system, so it's like a shared platform. So that can be in the public cloud. So this is all about hybrid cloud. And the last one is multi-cloud. There's not a single environment like others. Okay, so it has to use multiple cloud providers. Say for example, they will use Google, also they will be using Azure, they will be using AWS. So one organization may use all the three platforms, Google, Azure and AWS. So they'll be using many cloud environments. So that is called as multiple cloud. Why they are using it? Because they wanted to avoid the vendor lock-in. So vendor like service provider, when the service provider has some limitations, so you wanted to get the best out of all the three people, all the three vendors, okay, all the three service providers, you can opt for different clouds. So a person may have to see nowadays, like most of them have two numbers. Their phones can accommodate two SIM cards. So one will be Jio, the other might be Airtel, Vodafone, SL we are not using it. So one will be Geo, the other one will be a different network. The other one will be old number, which you don't want it to discard because you have some sentiments with the phone number, or that phone number you have shared it to everybody for UPI. So you don't want it to discard that number. So you'll be using two networks in one phone, but service providers are different. One is Geo, the other one is different. Okay. So like that, the same way here in multiple cloud, you will use different providers where you will use the advantages of the providers. Okay, when one provider is causing some trouble, like maybe they have changed some policy, they have increased the cost, you can cut it down and go for the other cloud environment. Okay, say for example, in your institution or an organization, AWS, Amazon Web Services, can be meant for databases, Google Cloud Platform for AI tools, and Azure for enterprise applications. So you can divide based on the domains and needs, you can divide them and opt with different service providers. So we have an advantage of using many providers. Okay. Next comes cloud-based data science architecture. This is a generic architecture. There are there are specific architectures based on the models that you opt. But generically, this is a generic architecture where we involve data science, data sources, which has databases, cloud storage, IoT devices, and we have storage, which will talk about storage of voluminous data, not simple data storage. It deals with volumes of data, okay, large database, big data storage, and processing can be done using different computing technologies like distributed computing, stream processing, and data integration. And finally, we have the analytics, because since data science is involved in the cloud environment, of course, machine learning has a role, as a very important role to play. So AI model training and machine learning data analysis is done. And finally, to see the results of whatever we have done, we have the visualization part, where we will end up in seeing the results in graphs, heat maps, that can be anything, charts, diagrams. Okay, so that is all about visualization. Now we'll see in detail about the cloud-based data science architecture. They have different layers. We'll see 4 layers are there. We'll see one by one. The first layer is data sources. So the data sources talks about the sensors of IoT. So whatever the sensors are used to collect the data. Weblogs are also used for collecting the data. And databases, so the databases in the data source is small database where it is meant for collecting the data. This is not for storage. So here the data base which is meant here is for collecting the data, not for storing. So social media analytics is also done, where social media mining is done. All the data is taken from the social media. And of course data sets which is already there, like in Kaggle website, and there are many websites where data sets are available, and you can do web scraping also. So all these data are collected. That is what called as data sources. This is the first layer. So simple example is weather sensors, IoT sensors, which collects the weather data, that collects the temperature data. That is a simple example. This is in the first layer. Second layer is cloud storage. Here you have to store everything in the form of object. We know that a database has a different format of storing the data. When you're talking about cloud storage, it is called as object storage. That is what followed in Amazon and Azure. Okay? So here we call them as a data lake. So all the storage part is called as data lake. So we already know that what is data warehouse. It's like we store a lot of data, and we do data mining with the data warehouse. Okay, so data lakes are centralized repositories that store large volumes of raw data. So data lakes will store the raw data. It will store the data in the original format. Okay, it's not mostly structured. It might be semi-structured or unstructured data. It's like a big reservoir. It stores everything, different files. Okay, so it is very cost effective. And this, why we are using data lakes, is because data lakes are used for doing this analytics, okay, using machine learning or artificial intelligence and big data processing. So that's why we go for data lakes. And what object store does is it handles the large and unstructured data. And as I told you, it is highly durable and it is good in cost terms also. Okay. And we know about data warehouse. We have studied it's like collecting data from multiple sources, cleaning it, structuring it, and storing it in the central system, optimizing it, and finally you use it for the business intelligence. Okay, so data warehouse is like well-organized library. You store everything and use it. Okay, so it's like a centralized database. Okay. Next layer is data processing. Here you will do batch processing. You will do stream processing. So there are tools like Spark, Hadoop, or Kafka, or CloudPub. These tools are used for taking care of the batch and stream processing. Say, for example, if you wanted to process a 1 terabyte data, okay, so student performance data set is taken, and that can be converted using the Spark. Spark is a tool for doing the batch processing. Okay, so next layer is analytics and machine learning. Here we can use either Colab or Jupyter notebooks or AutoML services to do the analytics part. So when you wanted to do some analysis on the data and to get the reports, so here the machine learning and AI plays an important role. So all these ML frameworks also use, like TensorFlow, PyTorch. So one example is given here is training a student dropout prediction. So based on the data set which we have already available, if you want to find out the details of us, if you wanted to find out or predict a student dropout, so why a student is dropping out, what might be the reason. So if you wanted to do the prediction, especially in government schools, there are many dropouts. So many tools are available to analyze this. Government also wants to know why there are more dropouts in government school. Like in 2012, I did a research project to NCRT. It's like a very long period, 2012. So I submitted a research project to NCRT. I hope you all know about NCRT. It's a central board for, they write books, all those things. So there I did a project on why there are so much of dropouts in government school. What is the reason? You wanted to do an analysis. In 2012, AI and machine learning was not popular. So we were using some multimedia systems to predict and to analyze why there are a lot of dropouts. Okay, so we did a project on that. And next, final layer is visualization reporting. So here we have charts, heat maps, bar charts, graphs, pie charts, anything. Okay, so there are a lot of reports, dashboards, and APIs are there. All these dashboards are interactive dashboards that will give you everything very clearly. So the analysis part is over with the visualization. right? Next comes the data science life cycle in the cloud. So how data science works in the platform of cloud? What are the different steps? So there are 5 steps here. It starts with data ingestion, and the second one is data storage, and third one is data processing, and fourth one is model development, and finally deployment and monitoring. Monitoring is to check the progress. So these are the different stages. So we'll see one by one. The first one is data ingestion. What is ingestion? Ingestion is collecting of data. It's like data collection. So you have to collect the data from different sources, and you have to load it in a particular target. So it will be loading into a particular system. So it's like data lake or data warehouse. So it can be stored, data can be stored, processed, and analyzed. Okay. So in simple words, you can say that data ingestion is how the data is collected. So is it based on data sets, or you're doing web scraping or real-time streaming, or you're collecting all the data through APIs. So how we are going to extract the data from the data source. And after extracting the data, you have to validate it. Okay, you have to validate it because you have to use the right data. You cannot use a falsified or a fake data. Okay. Second thing is data storage. Here, the data is stored in different platforms. It can be in raw zone if you're collecting the data as a raw data, original data. You store it in the raw zone. If you're cleaning it, if you're processing it, maybe you wanted to apply some filters and remove the noise, then that is segregated in the clean zone. Okay, once everything is done, see, for example, you have to look for it's like pre-processing, right? You will do everything, and that is taken in the curated zone. And step 3 is data processing. Here you will do the cleaning, transformation, and feature engineering. So these are the 3 steps under data science life cycle. We have few more steps also. The 4th step is model development. Here you look for the model. So it can be an algorithm, or any model, or a strategy, and a training is required, and you have to do the validation. So this will be carried over in the model development. And the next step, that is the final step, is deployment and monitoring. So you start with collecting the data from different sources, you process it, clean it, and optimize it, and apply some models and algorithms, train it and validate it. And finally, what you have to do is you have to deploy that into the particular environment, the client's environment. Okay. So after deployment, that is, you're going to install it. And after that, you have to perform continuous monitoring, because we don't know what will happen. So when you do a pilot study, the system may work, but when you actually implement it in the actual environment, what will be the result? Okay, so that compatibility issues we have to check. Okay, so deployment and monitoring not only installing that system in the client's place, it also looks for monitoring of the system. So it will be a continuous monitoring where it involves a lot of tracking systems based on the performance and optimization. So there are tools to perform these tracking things. So AWS, Google, Azure, and these tools, Google and Azure, all these tools are good in doing the performance tracking. So these are the 5 different steps in the data science life cycle model. Okay. So as we discussed earlier, talking about the cloud data science tools and stack, these are the 3 important popular cloud platforms. One is Azure, Microsoft's Azure. Second one is Google Cloud Platform, GCP, and third one is AWS, Amazon Web Services. These are 3 popular cloud platforms. I have worked in Google Cloud Platform, GCP, and Amazon Web Services. I have explored AWS and Google Cloud Platform, but not with Azure. So let's see some of the important tools under the cloud and data science. So we have given the different stages also. So based on the stages, we can go with different tools. So for data storage, we can use a tool called as S3 and Blob. And for processing of data, we can use Spark and Databricks. And ML part, that is the actual analytics part, we have tools for cloud data science tools like SageMaker and Vertex AI. And for visualization, Power BI is good, Tableau is good. And comparing Power BI, Tableau seems to be very interactive. We have done projects on Tableau that seems to be very appealing. Okay, so you can have an interactive dashboard in Tableau. Okay, And notebooks, I think everyone would have explored Jupyter and Collapse. That these are common tools that we encounter during our curriculum development in academics. And even Power BI and Tableau, people would have explored it. So these are some common and popular tools that can be used for cloud and data science together on different stages like data storage, processing, ML, visualization, and notebooks. So now we are in the last part where we have to discuss on the challenges. What are the challenges? What kind of best practices that can be followed and how the future will be. Okay. So challenges are privacy of data, because cloud has a shared resource where security seems to be a difficult task, because nowadays we have many cyber attacks, many attacks in the digital platform. So when we connect data and everything with global accessibility with internet, the question on security part is there. And cost management. So we have to pay only for the resources that we use. You should not pay for everything. So cost management should be done. It's like budgeting for a family. And skill gap is that, like, you cannot expect everyone to know how to use AWS, everyone to know how to use Tableau. So experience on practice should be given. So people should be trained with these tools. Then only they can know about it. Okay. Next comes the vendor lock-in. So vendor lock-in, excuse me. Sorry for the interrupt. Okay, so we were talking about the vendor lock-in, because service providers, they may change the policy, they may charge more. There are some problems in it. So what are the best practice that we can go is, like, you start with small, everything. Whatever we are exploring something, if something is new, start with small, start with basics, and you can scale later. And you can use a managed services which is offered by different platforms, and ensure to look into the governance policies, and there should be proper tool constructed for cost monitoring, because these tools, they take a lot of cost. So cost management should be done. So what are the future trends in the cloud and data science platform? One is serverless data science. So in future, you will not have servers. The data science, you will have auto ML, that is completely autonomous machine learning systems. They will train their own systems. The model will develop everything. Self-training will be given. Auto learning will be there. And of course, everything will be AI powered, and edge computing will combine with cloud analytics. So edge, that is AI, and cloud analytics will be the emerging trend in future. So these are the future trends for the cloud services. So in the summary, cloud is the backbone of modern data science. Okay, so we have many technologies. So cloud will be helpful to connect with many technologies along with the data science. The architecture here is also, we should know the architecture of cloud. That is very important, because people should know about the cloud platform, and we should focus on the life cycle, not just the models. And cloud enables scalability and collaborative research. So the outset, cloud era, data science is not about tools, it is about architecture, scalability, and impact. So a combination of all those things will help to combine or integrate cloud and data science. Okay, so that's all for today. So this is a summary of today's session. So now it's time for asking questions. If you have any questions, you can ask. So whenever you would have seen cartoons, I think when we were young, you would have watched many cartoons, right? When you wanted to think about, immediately cloud comes, a light comes. Okay, so if you have any questions, you can ask. Any questions? So feedback form is shared, so everybody will be busy in filling that feedback form, because that's mandatory as per the governance. So I've shared my email ID. If there are any questions, if you wanted to do any collaborations on research or anything, for any academic collaborations, for research proposals, projects, whatever it is, Any collaborations related to academic, I'm happy to help and I'm happy to connect. So I've shared my email ID in the chat window. You can write email. And any questions? I think one ma'am is having a question. So I understand late evening, everybody have many chores to do. There are no questions. We can.
Anybody can have question? Please raise.
Yeah.
Participants are requested to feel free to ask questions.
Usage of multi-cloud. There's a question in the chat window from Barnidharan sir. So thank you for asking a question. Usage of multi-cloud with respect to data science. So as I mentioned you earlier, multi-cloud can have two different. I mean, you can have different clouds. You can use public cloud or private cloud. You can use all these things together, and you can have different providers. So, say for example, you can get. Google, you can use Google Cloud for one particular domain. You can use AWS for another and Azure for another. So there are three platforms that you can use. Like they are like three providers. Okay, the advantage is like you get the advantages of all the three. So if you don't like one provider, you can simply discard it and you can go for the other provider. So that is the advantage. Okay, so you can have the options to have an option for flexibility. There are more advantages in it. Okay. Thank you for asking questions, sir. Thank you. Any other questions? You can post in the chat window also if you want. Okay, and I've shared my email ID. Anyway, if you have anything, you can write. So thank you very much. Thank you so much for participating and spending your quality time on this. Happy learning. Thank you so much. Once again, thanks to the organizers, organizing team and Wales University. Thank you so much. I'm over to you.
Thank you, sir, for your inspiring, insightful address. I now invite Mrs. Mary Shiba, Assistant of DACE, to kindly propose the vote of thanks. Over to you, ma'am.
Okay. It's my great privilege to propose a vote of thanks on this occasion. On behalf of this organizing committee, I extend my heartfelt thanks to our respected Chancellor, Vice President, and other management members for their constant encouragement and guidance, which have been an instrumental in making this program a success. I take this opportunity to express my gratitude to our distinguished resource person, Dr. Vignesh Ramamurthy, Associate Professor, Department of Computer Applications, Amity Institute of Information Technology, for delivering such an insightful session on cloud-based data science, its architecture, and cloud data science tools and stack. Thank you, sir, for sharing valuable knowledge with us.
Thank you, ma'am. If it is really insightful, I'll be very happy. Thank you so much.
Yes, thank you, sir. Yeah, special thanks to our HOD ma'am, Dr. R. Devi, and the organizing committee members for their constant support and dedicated efforts. I extend my gratitude to all the participants for your active engagement and patience throughout the session. Thank you once again to everyone for your presence and contribution. Thank you.
Once again, I thank you for all your active participation and support. Thank you and have a great day.
Thank you everyone.